Hey guys, welcome back. This is Lei. In the last video, I showed you how to perform differential expression analysis. In this video, I'm going to show you how to visualize the DE results. Basically, I'm going to show you how to make volcano plots, heat maps, bar plots, Violin plots, and box plots. We need an R environment. You should have already installed all the essential packages by now. If not, just go ahead and install them as shown here. Once installed, we just load them using the library function. Among the packages, ggplot2 is the core package for data visualization. Many other packages are either based on ggplot2 or the extensions of it. In data science, ggplot2 is so popular that many Python users learn R just to use this package. The reason why ggplot2 is the best is its intuitive syntax structure. It's pretty much like Photoshop. In Photoshop, we have layers. We sketch in the first layer, we refine the drawing in the second layer, add colors in the third layer, and so on. In ggplot2, we add data in the first layer, aesthetics in the second layer, shapes in the third layer, and so on. Here is an example of making bar plot using ggplot2. Bar plots show the average of groups. In our case, we're plotting the average expression of gene icon. As a data scientist, our first step is always to prepare the data. So for this case, we need a data table with 3 columns: treatment column, mean column, and standard error column. Once we have this data table, we add it to our first layer. We specify X and Y axis and colors of the treatment groups. We add the shape in the second layer and arrow bars in the third layer. We can also add labels and themes in different other layers. This is the basic syntax of ggplot2. We then concatenate all the layers using the plus sign. We can make it even more complex figures using more layers. Here, let's practice more by making a Violin plot and a box plot. Again, the first step is to prepare the data table. Box plot and Violin plot show the expression of a gene in all the individual samples. So we need 2 columns, the treatment column and the expression column. Once we have it, we add it to the first layer, specify X and Y. We add the shape, Violin shape, in the second layer. We can add another shape, jitter, means dots, in the third layer. We can also add more layers, like mean and arrow bars, in the fourth layer. And then we have labels layer and themes layer. To make the box plot, we just simply replace the shape layer with the box plot, and everything else stays the same. Box plots don't need a mean and arrow bars, so we just skip the stat summary layer. And this is the syntax for all ggplot2 plots. We can also make volcano plots using the same way. Volcano plots shows the log for change and p-values of DEGs. So we're gonna prepare our DEG table. We add 2 more columns here in the DEG table, a negative log 10 p-value column and a regulation direction column. Because p-values are really small, we don't want to plot small numbers, so we just want to plot the exponents in this case. That's why we have the negative log 10 column. The regulation direct column can give us colors of DEGs. Once we have the table, we add it to the first layer, specify X and Y axes, and we're gonna plot points. So we use the gene points shape layer, and we can specify the colors manually, like up-regulated as red, down-regulated as blue, and non-significant as gray. We can also add vertical lines to show the range of log field change and horizontal lines as a p-value threshold. And then we can also label the top expressed genes like this by adding another layer, the text repel layer. And then we have label layer and theme layer. And this is much more complex, but the logic and the syntax are the same. But there's another easy way to make Volcano Plot by using the EhancedVolcano package. You can make the Volcano Plot using one command, one function, EhancedVolcano function. The only thing we need is the DEG table. And you can specify X and Y and cutoff. And also you can specify colors of down and upregulate genes as a way, same way in the ggplot. The Volcano Plot, the EhancedVolcano package is based on ggplot2 package. So we can save the results using the ggplot2 saving function, the ggsave. However, there's one problem that EhancedVolcano package doesn't do a good job labeling the genes in the plot. So if you want to label genes in your plot, you better use the ggplot method in the last slide. In the same way, we can also make Heatmap using a Heatmap package. And it's going to be very simple by using one simple function. But again, we have to specify our data table. Heatmap shows expression patterns of multiple genes. So here we need an expression matrix, but we don't need all the genes. We only want to plot the DEGs. So we subset the gene expression matrix. You can also make a column annotation table in this format. This table will label the groups in the heatmap, but it's optional. It's up to you. So once we have the expression matrix, we feed it to the pHeatmap function like this, and that's it. That's very, very simple. Just one function, one step. You can specify the colors like this one. You can label the groups using your column annotation table you just made. You can cluster rows. Rows represents the genes. And you can allow the column names and the gene names if you don't have many DEGs. Unfortunately, pHeatmap doesn't have a save function, so I wrote my own. You can just copy it and use it. Save the heatmap to your computer. And that's all of the figures to make in this video. So you can go ahead to my website and copy the code and try it on your own. In the next video, I'm going to show you how to do the pathway analysis.